Hello, my name is Rafid Kaser. I'm one of the authors of our chapter on component-component interfaces in spine surgery. We hope the reader finds this chapter educational in understanding these components that make up our spine implants, as well as the forces that hold those components together. Before we delve into the component-component interfaces, let's understand the components that make up our spine implants. I have brought with me a model to demonstrate some of the commonly used components. They can be divided into three classes in general. There are anchors, there are longitudinal connectors, and there are cross connectors. In this case, in the lumbar spine, we have anchors, which are the green screws that were placed into the pedicles. These are connected to each other with a longitudinal connector. In this case, it's a rod. And the two rods are connected to each other with cross connectors, which increase the overall stability. There are other anchors we can use, and even if we use screws, we can place them in different locations and use them in a different manner. In this case, we have the pedicle screws. If we go to the cervical spine, we can use lateral mass screws. Oftentimes the pedicles in the cervical spine are smaller, therefore it's safer to place them in the lateral masses. We can also place them in the lamina in certain cases. Even further, we can place them into the vertebrae. If you approach the spine from an anterior aspect, as we see here in the cervical spine, the screws were placed into the vertebrae. We can also do the same in the lumbar spine, and we can place them laterally as well if needed. There are other anchors we can choose. We can choose hooks, and we can choose wires. These can be placed around the lamina, around the pedicles, around the transverse processes, and even around the spinous processes. There are other longitudinal connectors we can use besides the rods. We can use cords if less rigidity is desired. And we can use plates, as seen here, into the anterior cervical spine, into the anterior lumbar spine, the lateral lumbar spine, etc. Furthermore, if we do a corpectomy, as seen here, we can place a cage in that site, and that can be considered a longitudinal connector. A smaller cage can be placed if you do a discectomy, and that can be considered a longitudinal connector, connecting two anchors in each vertebrae. Now that we understand the components that make up our implants, we can understand the component-component interfaces. Dr. Benzel does an excellent job of illustrating 7 commonly employed techniques of holding a longitudinal connector against an anchor. Essentially, all of these techniques employ the force of friction to do their job. The force of friction equals the coefficient of friction times the normal force acting against the two objects in contact with each other. For example, if I take my palms and place them against each other, the force of friction equals the normal force, where I'm pushing my palms together, as well as the material properties between my two palms. The coefficient of friction in this case is much less than if I were to put my knuckles together and interlock my knuckles. The force of friction would be greater. Therefore, when using the same normal force, pushing my hands together, it would take a much larger force to slide my fists against each other than it were if I were to place my palms together. Understanding these concepts is important in understanding the interfaces in our components in spine surgery, and we hope the reader finds this chapter very useful in their endeavors in understanding this topic. Thank you.